Greetings of the day. I am Dr. Onika Parmar and I welcome you all in today's lecture. Today we are going to discuss about 1 cross 2 demultiplexer, 1 cross 4 demultiplexer, 1 cross 8 demultiplexer. Today's class is the introduction to demultiplexer and will also cover 1 cross 2, 1 cross 4 and 1 cross 8 demultiplexer. A demultiplexer often refers as a demux or in capital letter DMUX in a digital electronic device used in digital circuit and communication systems. Its primary function is to take single input line and distribute the data or the signal to one of the several output lines. This is based on the control signal. Essentially, it performs opposite operation as that of the multiplexer, which combines multiple inputs into a single output line. So today we are going to have detailed discussion on multiplexer, characteristics and component of the demultiplexer, 1 cross 2 demultiplexer, 1 cross 4 demultiplexer, 1 cross 8 demultiplexer. We will discuss about their truth table and the logic diagram. Followed by that, we will discuss about the 8 cross 1 demultiplexer and we will design this 8 cross 1 multiplexer using 1 cross 4 multiplexer and 1 cross 2 demultiplexer. So, a demultiplexer, often abbreviated as demux. It is a digital electronic device that performs the reverse operation of a multiplexer. While a multiplexer takes multiple input and route them to single output, a demultiplexer takes single input and distribute into several possible combinations of the output based on the control signals. Demultiplexers are fundamental component in digital circuits and communication system, serving various purposes including data distribution and signal routing. They are commonly used in applications such as telecommunication, data transmission and memory addressing. A demux or a demultiplexer basically reverses the multiplexing function. It takes data from one line and distribute them to given number of output lines. This figure shows a demultiplexer. In this figure, we see one line of 4 line demux. Here we can see the data, a single data is present at the input and we have 4 data lines at the output. So, this becomes a 1:4 multiplexer. Now, the data is provided at the input and the selection lines, here we have 4 inputs. So, we will require 2 selection line. These 2 selection line will decide which data to be given at the output. The selection line plays a significant role here. The combination of the selection line 0 0, 0 1, 1 0, 1 1, which it will decide the data which will be given at the output. So if we suppose have logic high at the input and the selection line has the combination of 0 1, then the input 1 will be provided at the second output line. For suppose the selection line has 0 0, then the data at the input will be reflected at the output D0. This figure shows 1 line to 4 line demultiplexer circuit. The 2 selection line enables only one gate at a time, and the data appearing on the input line will pass through the selected gate to the associated output line. This is the logic diagram for a 4 output demultiplexer. Here we have one input line and the combination for the selection lines, that is S0 and S1, and depending upon the combinations the data input is transmitted at the output line. So here if we see a black box here, we will get one data line at the input along with 2 selection lines. Output will have 4 lines. A demultiplexer is a combinational circuit that has only one input line and 2 to the power of n output lines. Simply the demultiplexer is a single input and multiple output combinational circuit. The information received from the signal input and directed to the output line. We have only one input line and multiple output line, and the selection line selects which output line to be the data to be transmitted. On the basis of the values of the selection line, the input will be connected to one of these outputs. Demultiplexer is opposite to the multiplexer. Unlike encoders and decoders, there are n selection line and 2n outputs. So there is a total of 2 to the power of n possible combinations for input. Demultiplexer is also called as demux. So let's discuss the characteristics and the components of a demultiplexer. So first of all, it is a single input device, that is data input. A demultiplexer typically has one input line where the incoming data signal is applied. Multiple outputs. Demultiplexer have 2 or more output lines, each corresponding to different destinations or channels. Control inputs. Demultiplexer have control inputs that determine which output channel the input data will be directed to. The number of control inputs depend on number of output channels and can vary from 1 to several bits. Now let's discuss about the truth table. The relationship between the control inputs and the output channel is defined by a truth table, which specify the routing of the input data based on the control inputs binary value. There is a decoder function. Demultiplexer can be thought as a decoder circuit, as they decode the control input to select one of the output channel. So let's discuss about a 1x2 demultiplexer. In the 1 to 2 demultiplexer, there are 2 output lines, that is Y0 and Y1, one selection line, that is S0, and a single input A. On the basis of the selection line or on the combination of the selection line, the input value will be connected to one of the outputs. So this shows a block diagram for a 1x2 demultiplexer. Here we have one single input A, then we have an enable line along with the one selection line, and there will be two outputs Y0 and Y1. If let's say S is equals to 0, then the value of A will be transmitted at Y0. If S is equals to 1, the value of A will be transmitted to Y1. So, the logic expression for the term Y is as follows: Y0 is equals to S0 bar dot A and Y1 is equals to S0 dot A. The truth table for 1x2 demultiplexers are shown here. So this is the truth table for a 1x2 demultiplexer. Here S0 acts as input and at the output we have Y1 and Y0. And if we have logic low at S0, our Y0 will have the input value A and Y1 will have 0 at the output. If our S0 is equals to 1, whatever value present in A will be reflected at Y1 and Y0 will represent 0 or logic low. Logic diagram for 1x2 demultiplexer is shown here. This shows the logic circuit for the above expression we have discussed. So here we have one input line and the combination of the selection line. S0 along with A is provided at the AND gate and the output is taken as Y0. The selection line along with A is given to the second AND gate and the output is taken as Y1. So let's move ahead and discuss about 1x4 demultiplexer. In 1:4 demultiplexer, there is a total of 4 outputs, that is Y0, Y1, Y2 and Y3. Two selection lines are S0 and S1, and as the demultiplexer have only one input, so a single input line A. On the basis of the combination of inputs which are present at the selection lines S0 and S1, the input be connected to one of the outputs. So this block diagram shows a 1x4 demultiplexer. It has one input line A and two selection line S0 and S1 along with 4 outputs Y0, Y1, Y2 and Y3. So this is the truth table for a 1x4 demultiplexer. The truth table for the 1x4 demux is shown here. It has S1 and S0 at the input and outputs are Y0, y1, y2 and y3. So, if our selection line has the combination 0, 0, then whichever value present at the input A will be reflected at output y0, and y1, y2 and y3 will have logic low at the output. If a selection line has the combination 0, 1, in that case whatever value present at the input, that is A, will be transmitted to y1, and the selection and the output lines y2, y3 and y0 will have logic 0. If our input lines or the selection line have value 1, 0, in that case y2 will reflect the input and y1, y0 and y3 will have logic low or 0 at the output. If the selection line has the combination 1, 1, in that case y3 will have the value of input, that is input will appear at y3 along with y0, y1 and y2 will have logic 0 at the output. The logic expression for the term y is given as y0 is equals to S1 bar S0 bar A, y1 is equals to S1 bar S0 A, y2 is equals to S1 S0 bar A, y3 is equals to S1 S0 A. This shows the logic circuit for the above expression which we have discussed for a 1x4 demultiplexer. Here the selection line combinations along with the input A are provided at the input of the AND gate. So here we can see there are 3 input AND gates, and the selection lines along with their inverted values according to the combination or according to the expression which we have discussed are provided at the input of the AND gate, and the input of the AND gate have this value of A, S1 and S0. Now we will have Y0 to Y3 at the outputs of this AND gate. So if we consider a black box outside this logic circuit, we will have a single input line A along with 2 selection line S0 and S1, and we will have 4 outputs, that would be Y0, Y1, Y2 and Y3. So let's move ahead now and discuss about a 1x8 demultiplexer. In 1:8 demultiplexer, there is a total of 8 outputs, that is Y0, Y1, Y2, Y3, Y4, Y5, Y6 and Y7. To have 8 output lines, we will require 3 selection lines. So these 3 selection lines will be S0, S1 and S2, and a demultiplexer is a single input device, so there will be only one input, and let's assume it to be A. On the basis of the combination of inputs which are present at the selection lines S0, S1 and S2, the input will be connected to one of these output from Y0 to Y7. So this is the block diagram for a 1x8 demultiplexer. Here in this diagram, we have 8 output lines from Y0 to Y7 respectively, and we have one input line A along with the 3 selection line S0, S0 and S1. So this is a 1x8 demultiplexer, 1 input and 8 outputs. This is the truth table of the demultiplexer, and according to the selection line, according to the combination of selection line S0, S1 and S2 will have the outputs. The output will be Y0, Y1, Y2, Y3, Y4, Y5, Y6, Y7 respectively. If our selection line gives the input 0, 0, 0, then Y0 will have the value of A and the rest will have logic 0. If our selection line has the combination 0, 0, 1, in that case Y1 will have A and rest of the output will have 0. In the third case, if our selection line is 0, 1, 0, in that case Y2 will be having A and rest of the outputs will represent 0. If we have 0, 1, 1, in that case Y3 will give the input value A and rest of the output will have logic 0. For 1, 0, 0 at the selection line, will have Y4 having the value of A and rest of the outputs will show logic 0. For 1, 0, 1, Y5 will have the value of input A and rest will have logic low. In the case of 1, 1, 0 for the selection line, we will have Y6 showing the input value A and rest will have 0 at the output. And for the final combination of S0, S1 and S2, that is 1, 1, 1, if the selection line has 1, 1, 1 at the input, then our output will be at Y7 representing the input value and rest will have logic 0. So the logic expression for term Y is as follows: Y0 is equals to S0 bar, S1 bar, S2 bar A. Y1 is equals to S0, S1 bar, S2 bar A. Y2 will be S0 bar, S1, S2 A. Y3 will be S0, S1, S2 bar A. Y4 will be S0 bar, S1 bar, S2 A. Y5 will be S0, S1 bar, S2 A. Y6 will be S0 bar, S1, S2 A, and Y7 will be S0, S1, S2 A. So depending upon this logic expression discussed, we will have this circuit, or this is the logical combination for a demultiplexer. Here we can see there is a combination of the selection line S0, S1 and S2 along with the input line A, and we will have 8 AND gates present here. These AND gates will be provided the input logic as according to the logic expression provided, and according to this logic operation we will have output, that's S0, that's Y0 to Y7. So let's discuss how to design a 1x8 demultiplexer using 1x4 and 1x2 demultiplexer. We can implement a 1x8 demultiplexer using the lower order demultiplexer. To implement 1x8 demultiplexer, we will require two 1x4 demultiplexer and one 1x2 demultiplexer. So 1x4 multiplexer has two selection line and four outputs along with one input, while 1x2 demultiplexer will have only one selection line, one input and two outputs. For getting a 8 data output, we require two 1x4 demultiplexer and one 1x2 demultiplexer to produce two outputs. So in order to get final output, we will have to pass the output of 1x2 demultiplexer as input of both the 1x4 demultiplexer. So this is the diagram for a 1x8 demultiplexer using 1x4 and 1x2 demux. Here we can see at the output end we have two demultiplexers of 1x4. So in total we will have 8 output logics. Now for this 1x4 demux, we will require two selection lines. Now these two selection lines will be S0 and S1. Now the input is connected with a 1x2 demultiplexer, and the output of this 1x2 demultiplexer will be provided at single 1x4 demux. That is, the first output will be connected to the first demux and the second output will be connected to the second demux. Now a 1:8 demultiplexer has 3 selection lines. So 2 selection lines will be provided at the inputs of 1x4 multiplexers, that is the selection lines for 1x4 multiplexers, they will be shorted. Let's say S1 and S0 are given at the 1x4 demux. So S0 will be given to both the demux and S1 will be given to both the 1x4 demux, and S2 will be provided at the input of the 1x2 demux. So there will be 3 selection lines, they will be distributed in this manner, and the 8 output line are provided with the 1x4 and 1x4 demux. Along the single input line is given at 1x2 demux, and the output of this 1x2 demux is provided to the 1x4 demux. So in this manner we can design a 1x8 demultiplexer. So in today's lecture we have discussed about the demultiplexer, its characteristics and components. Along with we have discussed the 1x2 demultiplexer. We have seen the truth table of this 1x2 demux along with the logic diagram. Then we have moved forward and we looked at 1x4 demultiplexer, followed by its truth table and the logic diagram along with the expression. Then we have discussed about 1x8 demultiplexer. We have discussed its truth table, its expression along with the logic diagram. And finally, we have discussed about the designing of a 1x8 demultiplexer using two 1x4 demultiplexer and 1x2 demultiplexer. So, this discussion have a clear understanding about the demultiplexer. These demultiplexers has various applications in the digital electronic world. They are widely used in the condition where we have to provide multiple channels to the single input. So, these demultiplexers play a significant role in those cases. Thank you for attending today's lecture. In the next lecture, we will be further looking for the applications of these multiplexers and demultiplexers. Looking forward to meet you in the next lecture. Thank you for today.